Hello everybody, tonight we're working on Chapter 6. The topic for Chapter 6 is repetition by using loops. And we're going to be looking at two basic loop structures with some variations and how we use loops to also traverse the contents of list boxes. So let's get started. The loops fall into a couple different categories when working inside of Visual Basic. The two general categories are do loops and for loops. Now when you move to different languages, do loops will typically be called while loops, and you'll see that syntax inside of Visual Basic, but it's important to understand that Visual Basic is one of these old languages, so they kind of approach kind of the syntax of it in their own unique way. But it is basically the same type of loop that you probably will see in other languages. The author indicates here that loops are one of the more important structures in programming, and if you remember back to kind of that structured programming concept where we have sequence, selection, and repetition. Repetition is the last of the key programming structures that we are about to learn. And basically what it is, it's it's recognizing basically that often when you're programming, you run into scenarios where you perform a set of actions, and then often you'll need to repeat that set of actions to get to whatever result you want to get to. So that's why it's one of those real important ones. Now the way that a loop will operate will be something like this. So we look first at what we call a pretest loop. And what that simply means is before we execute the loop, we check for a condition. Checking for a condition would be kind of the same thing that we do like when we check an if statement. So we say, with an if statement, we say if. We might check to see if a value is less than or greater than or equal to, or if something is true or false or whatever the case may be. And if the condition triggers true, then we perform the thing that's inside the if statement. Very much like that, a do while loop does the same thing. Now, you might say, if I know that I'm going to repeat a certain number of times, why do I have a condition? Because you need to have some sort of a condition that checks to see if the loop should run, because if it just runs, you might get stuck there forever, right? So the reason that we have a condition statement inside of a loop is to check to see if the criteria is met. So if we were, let's say, to, lather, rinse, repeat, right? And then you lather and rinse, well, then you would check to see, are you doing it a third time? Well, if you are, you don't want to be doing it a third time unless you want your hair to fall out, right? And that's all BS, by the way. You guys know that, right? Unless you got really long hair and it's really dirty, then you can lather, rinse, repeat. All right, so very much like an if statement, we check a condition. If the condition registers true, the loop is run, and the statements that are within that loop can be one single statement or many statements. It depends on the program that you're writing. So after you perform the statements, then you will jump back and do the same statements, checking the condition. The condition still meets true, perform the statements, you jump back, check the condition. If it reads false, then you're done with the loop. That's the basic mechanics of a loop of this nature. Remember that this is a pretest loop. We test the condition before the loop runs. If you look at this in terms of both pseudocode and flowchart, you can see on the left-hand side here it says do while condition is true, processing steps, and then loop. In terms of a visual, our program flow would come in to the condition statement, check for true or false. If it happens to be false, we just skip it and keep going. If it happens to be true, we execute the statements, we loop back up, check the condition, and then depending on true or false, either we loop again or we jump out. So that's the structure of what a loop looks like, both in the pseudocode format and a flowchart format. Let's take a look at a little bit more of a concrete example here. Here we got a little subroutine that responds to a button click, and the author here has indicated what this should do, right? He's telling us, it says display the numbers from 1 to 7. And that's in there as a comment. So first he sets up a variable called num as an integer. He starts it at 1. And notice that he's setting this before we go into the loop. Okay? And that's a really important piece here. Because when he comes to the loop, he's testing. He's saying, is number less than or equal to 7? Well, we know it is because we set it right before, right? So as programmers, we're going to have that capability that we can trigger the loop to run no matter what. And often that is what we do. We want the loop to run. We just need to give it the impetus to run. But that num integer is being set prior to going into the loop. So we know this condition is true coming in. So will the loop run? Absolutely. And what is it going to do? It's going to put some stuff into a list box. And then notice what it's doing here. It's plus equaling 1 to num. So num started out as 1, and as the loop in its first looping through is changing to 2. So now num is 2. It comes up here and it says, is 2 less than or equal to 7? Yes. Outputs the 2, adds another one, goes back up. Is 3 less than or equal to 7? Yes. Displays 3, makes it 4. Is 4? Yes. Displays 4. It becomes 5. Yes. Still true. Displays the 5, becomes 6. Still true. Displays the 6, becomes 7. Loop or not loop? Yeah, we still loop because it's still less than or equal to 7. So 7, if num is 7, it will still run. So it'll display the 7. It'll add 1 to it, becomes 8, comes back up, checks the condition. All of a sudden the condition is false and the loop is done. Now I want you to think about this real carefully. There's two things that are happening. One is we are presetting num so that we make sure the loop triggers to run. And then secondly, inside the loop, we are changing num so that we have some hope of exiting the loop at some point in time. If we didn't change the value of num inside the loop, that loop would run forever. That's called an infinite loop, and that's not what we want. It's not considered a good thing. Now, there's going to be a couple little pieces of terminology here that are going to be pretty important for both testing and understanding, because you might move from language to language or a development environment to another development environment, and you'll hear people throwing terms around, and I want to make sure that you guys are fully aware of what the terms stand for. The one thing is that we will have often what we call a loop control variable. And in this case, num is that loop control variable. The value of num is really what controls the loop from running or not. So when we have a loop control variable in a pretest loop, we often preset the value. Okay? Now here in this one, there's a little bit of a change, and that is, in this case, instead of looking for a numeric value, we are looking for the entry of a password. Now this is kind of interesting because, you know, a lot of password routines work exactly in this fashion. So we preset a variable, and in this case it's just a variable called password as a string, and it's empty. Now what this loop will do here, it says while the password does not equal Shazam, we ask with an input box, which is kind of like a message box, but it's one that actually allows you to type in it. And it says, what is the password? So the person types it in, and this converts it to uppercase, checks, loops back up and checks to see did the person type in Shazam. If they didn't, it asks again. So it's not going to let the person in, or basically past this loop. You can look at it that way. Person can't get past this loop until they type Shazam. So it's actually kind of working on a reverse logic here, right? And if you think about that, you want that typically with a password, because if you don't get it right, you want to get another chance to put it in. So password prompting very often is done inside of loops, very much in this fashion, with whatever the criteria is, or the thing that you're checking to see if it's not equal to the correct thing, then we just keep looping until it happens. So the only way out of this is to type in the correct password. It's still a loop control variable, though. The password variable is still a loop control variable. Even though, I guess we are presetting it, but we're not giving it a value formally. We're waiting for somebody to enter that value, which they do while they're inside the loop. All right, another term that you'll hear people use as well is a Sentinel value. All right, loop control variable and a Sentinel value. When you think of the word Sentinel, you guys have probably heard that word, right? Does anybody know what the formal definition of a Sentinel is? Somebody Google it really quick. A soldier who guards and his job is to stand and keep watch. Thank you, Google. Yeah, he's the one that kind of controls what's going on, right? So when we say a Sentinel controlled loop, we're saying that the loop is controlled by a Sentinel value. And here they're telling us that -1 is the Sentinel value. Like Shazam was the Sentinel value for the previous password example. So you can't go past until you give the Sentinel basically the right value. All right, so let's take a look at this one here. And here we're setting up another variable called num, set it to 0, and then we're just putting in some string text here. But then we are going to basically put up an input box that has a prompt. So it's going to like a little message box. It's going to pop up. It's going to show us some text, and it's give us a spot where we can type in some information. And it's saying enter a non-negative number, enter -1 to terminate entering numbers. All right, so what this loop is going to do is it's going to check to see, is num not equal to -1? So if I type in any number aside from -1, it's going to let me keep typing numbers. Although we're being instructed to enter non-negative numbers, so that's kind of interesting in itself. So you put in 1, 2, 3, whatever numbers you put in, 50, 1,000, and then you're like, I'm done. Then you enter -1, hit the little button. It'll see that it finally does match -1, and then pop us out of the loop. And that's one of these techniques that you learn for both password prompts and for giving people a way to like exit out of, let's say, maybe a menu, right? Like if you put a menu up on the screen, say what's your choice, 1, 2, 3, or 4, or 5 to exit. It waits for 5, and as soon as you hit 5, you're out, right? So that's called the Sentinel value. Now, this is a do-while loop. Remember, we're checking the condition to run the loop before we run the loop. We preset the value for the loop control variable before we get to that condition check. That's required with this type of loop. All right, there is another type of loop though, and that's called a post-test loop. And what's interesting about this is notice that it does not check the condition until the loop runs at least once. Now that's kind of an interesting thought, right? So instead of like an if statement where it checks the condition and then does it, well, the first time through, it just does it. Then it checks the condition, and if the condition is true, it will do it again. If it's false, it will carry on. But remember, post-test loop, that means it runs the test, the condition test happens at the end of the loop, and then given that scenario, it will loop if it's true, but it always runs at least once, always. From an example standpoint, think of the password thing that we were looking at before. And what you're seeing here is, once again, we have that same password variable as a string, empty string, and then first thing it does is it just jumps right into the loop, and it asks us, hey, what's the password? You type it in. If the password equals Shazam, wait a second, is this working in reverse? It is working in reverse, because look at the terminology. Do while something is true, or do until something is true. So really what's happening here is if the person types in the right password, then we let them go through. Otherwise, it's going to keep looping, asking for that password. So you see the difference between the two now? Do until something becomes true, as opposed to do it while it's true. From a pseudocode and flowchart layout, this looks very much like the code. Notice with this one though, from a flowcharting standpoint, you come in and you do the first step, or whatever number of steps are in there, check the condition. Is the condition true? Yes, keep going. Is it not true? Loop back, do it again until it is. Now what's fascinating about that, and you're going to see an example, is notice, with this password one, how we were able basically to accomplish the same reprompting using two different loop approaches. A pretest and a post-test can both work. It's just a matter of setting up the logic to do it right. Now that's a really, I think, a very useful tip. If you set up your programming code correctly, you can usually accomplish most looping activities with any loop of your choosing, as long as your logic is structured well. I think that some scenarios are better suited for certain types of loops, but there's, I think, very, very few circumstances in which you couldn't accomplish anything you wanted to do with any type of loop, as long as you set it up correctly, or at least get yourself very close. All right. Next little example here is a little thing that calculates interest and how long it takes for you to become a millionaire. I always love these calculations, right? So this one here, we set up a variable called balance. It's a decimal. Years, it's an integer. With the balance, apparently that's the money that we put into, we type into the little form field there and say, oh, I have $1,000 in the bank, let's say. Then, since we have that preset, as long as your balance is under $1 million, then we will add to the balance times the interest rate. So that would be the annual interest rate. So how long would it take at 6% interest with that $1,000 you put in the bank for you to become a millionaire? That's really kind of the question here. How many years would it take? Not in my lifetime is usually what most people say, right? I'll tell you what, if the interest rates are high enough, and right now they're pretty low, and they have been pretty low for a couple decades now. But when I was, I'm looking at you guys, when I was like your age or younger, there were times where like the savings rates at the banks were like 7, 8, 10%. You put money in the bank and you just let it sit there, it would compound a whole lot faster than it does now. But our inflation was also much higher, and the interest rates we were paying on everything was also a lot higher. Like right now, you can get a mortgage for a few percentage points, 3, 4, 5%. Back then, you were lucky to get one for like 10 or 12 or 15%. So those rates kind of play off of each other. But when the interest rates are high, you can actually do pretty well. So what this would do then is it would just keep adding that money in there over and over and over again. And then every time it would keep compounding and it still hasn't reached $1 million, it would be counting the number of years. So every time it goes through, it also counts the number of years. But eventually, hopefully you get up to $1 million, and then your output might be something like this. So if you deposited $100,000, in 40 years you'll have $1 million. Right? You just have to have the $100,000 to start with and the 6% interest rate. Wouldn't that be nice? A couple little comments the author has here. It says, be careful to avoid infinite loops, loops that never end. You know what happens with a computer that's running an infinite loop? Well, yeah, in some cases it will. In the old days, they would just crash your computer. Just waiting forever for that loop to finish, and it would never finish. So it's not considered good. Now, Visual Basic also, it says here, allows for the use of either the while keyword or the until keyword at the top or the bottom of a loop, but the considered proper way to do it is do while and then loop until. That's considered the better approach. All right, there is another type of loop structure, and these are called for loops. And in Visual Basic, they call them for next loops. And just so you know, the previous loops that we were looking at, the do while, in most languages we call them while loops. And the keyword is typically while. So that's something to know. And you can, in most languages, you can also do a pretest and a post-test with the while loop. Now, a for next loop is a little bit different in that it's really kind of designed for when we know how many times we really want the loop to run in advance, right? So in other words, this wouldn't be the best option for getting a password, right? Where the person might guess 50 times before they get it right. This would be more ideal if we were reading in information from a file and we know there's 50 names on a list, so we run the loop 50 times, just for example. Notice that this is also what we call a counter-controlled loop because the counter mechanism is actually built in to the loop structure itself. So here's the syntax for this, and notice real carefully, I know that text is a little small on big screen here, but there's the keyword we have here is for I as, and notice what it says, man data type. Okay. Usually that will be an integer for counting. And then we're going to take that loop and run it so as this data type goes from one value to another. So for example, and you'll see this on the subsequent slide, I might say for I as integer equals 1 to 10, which means I would loop through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And I count it. So if you'll see on the next slide here that the author does, well, almost that, but very, very much the same thing. And what we have here is our counter variable, which is the I. We declare its data type. For I as integer equals 1 to 5. So that means the first time through the loop it will be 1. It'll come in here and and we're outputting to a list box, and apparently it says I, a space, and then what? Squares it, right? So it's going to display 1 space 1 the first time, because 1 squared is 1, right? Just nod and smile. Second time through, I is going to become 2 automatically, because that's just what it does. And then it'll list 2. What's 2 squared? 4. And then it'll be 3. What's 3 squared? 9. And it's going to continue until it gets to 5. It'll display 5, a space. It'll square 5, make it 25. And then it's done. It doesn't need to check anything. It just runs for a predetermined number of times. Right? So the incrementing of I happens automatically with every time we go through the loop. And actually, let's talk about a little bit of terminology here too while we're at it. When we loop, we're doing things over and over again, right? There's a word in the English language called reiterate, right? So when I say, hey, you reiterate what you just said, that means you're going to repeat what you just said. So every time you repeat it, it's a reiteration. Now the first time or a single time you say it, it's an iteration. So when we go through a loop once, it's called to iterate or an iteration, right? So one single pass through a loop. So if you ever hear that terminology, because you will hear people throwing that around in IT. Sometimes they think just to see if you know what loops are. Now, notice, now if I compare this do while loop, I can get the same effect that I got with the for loop, but notice how it takes a couple more lines of code? Because with while loop, in order to be able to preset that I have to do it before the loop starts. So I have to set up the I as an integer. In a for loop, that's declared right inside the for loop. In the while loop, then I know that since I preset it at 1, it's going to run as long as it's less than or equal to 5. And then I can get it to output the same stuff, no problem. It can print out the number and its square. But in order to change that I to the next value, I have to do an increment. I have to do a plus equals. I have to add 1 to it. With the for loop, that's not necessary. It happens automatically. So what you see with a for loop, once again, is if you know how many times you're going to run something, a for loop is the ideal loop. And a lot of programmers love them just for that reason, because I don't have to declare anything before it. It just runs a certain number of times. And then when I'm inside of it, I don't have to worry about incrementing that variable because it happens automatically with the loop structure itself. It just does it. All right. All right, so give us an example here. In this one, we have a variable called population, or pop. It's set as a double, and it's set to 300,000. And then we have a for loop. And for its loop control variable there is year, YR, as an integer, and it's going from 2015 to 2019. And unless otherwise indicated, and we're going to see it in just a few slides here, those numbers are going to increment 1 at a time. So it's going to start with 2015, 2016, 2017, 2018, 2019. And it'll run that many times. And then for each time it runs, it will display the year, and it's going to display the population in terms of what it becomes. So it starts at 300,000, so the first year it's going to say in 2015 the population was 300,000. And then population will have added to it a 3% growth. So when you look at this output here, and I think it's kind of funny how the they probably should have reversed these two slides. So 2015 is 300,000. We had a 3% increase, and then it just increments 1 year at a time automatically, and it'll add that percentage automatically as was dictated by this code. So I think that's a nice example of a for loop. There is something that we can add to the for loop to help it do things in different increments. So in other words, do I always have to count up by 1? That's what for loops do automatically, because typically that's what we do, right? We'll do it 1, 2, 3, 4, 5 times, right? That's how our brains think. But what if we want to count down instead of count up? Or what if we want to count by 2s or 5s or 10s, right? We want to check the population every 5 years or 10 years, that type of thing. Then we add a keyword to it called step, and it just gets appended to the end of the for loop, and then by that we can dictate what our step value is. So the implied step value when this isn't listed is the step is 1. It goes up by 1 each time. By doing this, this allows me to step down -1 each time. So that loop will run from 10 to 1. So what this will output is, in the list box, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then the loop is done. And it's counting down by 1. Yes, question?
So, this case for J, you use like a variable make earlier, or not earlier, so like an Xbox?
You could. You absolutely could. The question for those listening to the video is, for J, do we have to basically declare J here, or could I use a variable that was pre-declared somewhere else in the program? Absolutely, you can. You can do that. Now here's where your mind will start to bend and twist a little bit, especially if you've never been exposed to programming in loops before, and that is the capability of nesting loops inside of each other. All right, and this is pretty slick. All right, so what happens here is that by putting a loop inside of a loop, for every iteration of the outer loop, the inner loop must complete all of its iterations. So let me explain. The outer loop is going to run I as integer 65 to 70. So it's going to go 65, 66, 67, 68, 69, 70. Right? How many times is that? 5, 6, 7, 8, 9, 6 times. That's what it's going to do, 6 times. And then notice that it is going to grab the values of I for the inner loop as well. So for the inner loop, it's going to run 1 to 25. So for each one of the 6 times the outer loop runs, this is going to run 25 times. So how many total times will this loop run? 6 times 25 is 150 times. Now, that's kind of deep, all right? Because really what we're doing here is we're allowing this to run, this statement's going to run 150 times. We're only typing it in once, though. Each time it runs, it's going to take the current value of I and append to it the value of J. But notice that I is running through this character method. So the character method for I, the ASCII code, in other words, for I is 65, is the capital letter A. So what it's going to do is it's going to output A1, A2, A3, A4, all the way up to A25. The inner loop is done, and then it'll go back up. I will become 66, and then it'll go B1, B2, B3, all the way up to B25. Inner loop is done, goes back up to the outer one. So you see how that works? It's kind of a slick little thing. So if you wanted, you could extend that out through the whole alphabet, but basically it's possible to take a loop and put it inside of a loop. I know this is kind of deep for him to throw into the slide, show kind of like this early in the game, but it is a very useful structure to be able to loop inside of a loop. You might not see it initially, but if you think about, for example, what kind of things have things that are called A1, A2, A3, A4? Can you think of like maybe a spreadsheet, right? Yeah, for the battleship game. B2, you sunk my battleship, right? But you know, actually that's not really a bad analogy, because what this allows you to do really is to kind of really traverse a two-dimensional structure, right? Rows and columns, and be able to actually populate contents. And this is, folks, this is actually how they get stuff to be put into tables and columns and rows very often in applications, is by using loops inside of loops. And that's sort of a structure. All right, next slide. Now here the author is indicating, he says, for and next statements must be paired. So wherever you see the for, you have to have the next terminated. One is missing, the automatic syntax checker will complain and then give you this little error message. Now, going back to this whole concept of step values, what really is important to understand is that this is your start value, this is your stop value, and this is your step value. It can be positive or negative. If it is not indicated, it steps up by 1. Otherwise, by whatever value you put in. So if you wanted to do just even numbers, you would do step 2, and you would start with 0 or 2 or something like that, and it would go up by even numbers. Now, notice it says the loop will be executed exactly once if m equals n, no matter what the value s has. So if I say for I as integer 1 to 1, step 99, it'll still loop just once, because you're only going from 1 to 1. That's just how it works. The loop won't be executed at all if m is greater than n and s is positive, or vice versa if it's negative. One little caveat here. They caution you against changing the counter variable inside the body of a loop, because the for loop is designed to take care of its own counter. Where in a while loop, you are responsible as the coder for taking care of that. And messing with that basically can put you into the situation that can get you stuck there forever. So you don't want that. Right, he also puts in a little caveat here. It's not something we need to worry about too much, but he does indicate that double step values can lead to rounding errors, meaning that the loop is not executed at all the number of times that you're intending, so you really want to kind of avoid using doubles for counters. Integers work and decimals work, but I've run into very few situations where you need decimals, so integers are almost always the rule in this case. All right. So I often get asked, what's the point of having the structure of a loop? And loops really work very well with a lot of data structures that we're about to start learning about. One of them is a list box, because a list box is one of these structures where when we're doing output, we can do an item.add over and over again, and it just keeps adding lines, right? A loop is great for doing stuff like that. You'll also discover that loops are really good at reading in information from files and databases or to and from arrays. Very, very useful and doing stuff like that. Because ponder this as a thought, right? If I had a database that had a bunch of tables of information, or if you want to think of it as just like a list of names in a file, and it's maybe 1,000 names, I can set up a loop that will just automatically read through all of those one at a time and either put it on the screen or do whatever calculations we need to do. And that's why loops are such a powerful construct. All right, author now talks about some list box properties. Now, there is a little method that you can append to a list box. If you do listbox.items.count and you run that, guess what that does? It counts the number of things in a list box. Now, why that might be helpful is you could actually get a value and then use that value to help you predetermine how many times your loop needs to run. So it says, notice each item in a list box is identified by index number from 0 to whatever the last item is. But remember, since we start counting with 0, it can actually count. So if, let's say I had 10 items in my list box, the index value for the first one is 0, but the last one is going to be 9. And that's why there's a -1 at the end, because the 10th one, I have to subtract 1 to get it to the right index value. The count is 10, but the index value is 9. Now I know that's a little confusing right now, but when we go into arrays in the next chapter, that's going to be helpful, a very helpful piece of information. All right. So we can also use this syntax here where we use a set of parentheses and a number in place of n to indicate which item in the list box we're looking at. So if I was looking at the first one, I would look at 0. If I was looking at the second one, I would look at 1, for example. All right, and then I'm going to skip down here. There's also a way to actually take the stuff that's inside of a list box and actually, believe it or not, sort it, even though that's not like a real big focus of the stuff that we're doing in our homework, but it's kind of nice to know. So basically, what I'm telling you here is a couple of the previous slides and this slide really aren't going to be on any of your tests, per se. So that's kind of nice to know. But they do have a little bit of an example. So in this little application, you can see on the left-hand side, we have a list box that has the names of the states. And then we can run a little bit of code, which we'll see in the next slide, that would allow us to list the last 10 states. And you don't need to wrap your mind too deeply around this, but this is just how you might do something like that. And what it's doing here is right below the comment, it says display the last 10 states to join the union. He sets up a variable called n, which is equivalent to the count of the number of items in the list box. So if I have a list of like 50 states, counts them all, it says you got 50. And then our for loop is set up so that it goes from n minus 1. So if it's 50, it puts it to 49 because the last one's going to have an index number of 49. To that minus 10. So from 39 to 49 to 59 minus 1, so it does the last 10 states backwards. That's just in case you want to know. I don't think this example is too relevant to any of the stuff that we're doing. And folks, that's about all I'm going to cover in this chapter. And those are things that are pertinent to what we're doing as homework and things that would be on a test. So I've covered anything that would be in that scenario. Feel free to read the rest of the chapter. He goes into some depth on this stuff, but I prefer to talk about index values for contents when we talk about arrays, which will be our next chapter. So our focus here is mostly working with loops. So this lecture ends here.